Oh, hey guys, we are talking about still these linear relationships again. Oh, this table's dirty. We are, just linear relationships. So relationships that form a line, or equations that form a line when you graph them. Okay. So you got this first one right here. Um, we have 8-year-old Alex is learning to ride a horse. The trainer says that a horse ages 5 years for every 2 human years. The horse is now 50 years old in human years. How can you determine the age of the horse in human years when Alex was born? We've got this cool picture of a horse with a hat and birthday cake on it. So, yeah, you're welcome. Okay, so we've got a couple pieces of information here. We've got the fact that Alex is 8 years old, and we've got this whole thing, kind of like the age or how the horses age, and then we have the horse now. So I'm going to kind of like use this information here and here. So we have the horse is 50 years old and Alex is 8 years old. So I'm actually going to set up a table. I think that's probably the easiest way to do this. We don't have a graph on this. Um, so it's probably easiest to kind of represent this with a table. So I'm going to make a pretty big one here because we got plenty of room. I'm going to put Alex's age here. And put the horse's age here. Okay, so I know that Alex is now 8 and the horse is 50. And we'll kind of box that out. This may not be, this table is probably going to have weird sized cells, but that's okay. So we know that a horse ages 5 years for every 2 human years. So we want to determine how old the horse was when Alex was born, right, in horse years. So since we're talking about 2 human years, we'll basically just subtract 2 here to get to 6. And as we subtract 2 here, we actually have to subtract 5 for the horse. So when Alex was 6, the horse was 45. Then we go down 4 and then 40, right? As we subtract 2 on Alex's age, we subtract 5 on the horse's age. Then we get to 2, and then the horse was that's 40. Subtract 5 there is 35. And when we get to Alex's 0, we subtract 5 and we get to the horse was 30. Excuse me. So the age of the horse in human years when Alex was born is 30 years. So 30 years in human years for the horse. Gosh, that's a really weird way to say that. The horse is, let's do this, let's make it it'll make a little more sense. The horse actually was 30 years in human years when Alex was born. Okay. There you go. And so this brings in the concept of the y-intercept. We haven't talked about this yet. We've really only talked about slope when it comes to these equations. Basically how steep a line is or whether it's positive or negative. And so now, so far we've basically had every line that we've analyzed start at 0, 0. We've explored some lines, like just figured out slopes from lines that don't go through the origin at 0, 0. But now we're going to be like analyzing that kind of concept today. So yeah, that's the idea. Okay. Matilda and her friend are going bowling. She can rent shoes at the bowling alley or use her mother's old bowling shoes. That's exciting. How can she determine how much money she will save if she brings her mother's old bowling shoes? Man, she's pretty smart figuring out how to make those deals. Okay. So let's see, bowling prices including shoe rental. One game is $4, 3 games is $8, 5 games is 12, 10 games is 22. I'm gonna grab a ruler. We're gonna use rulers today, guys. Hold on. That's fun. Okay, sorry about that, guys. Okay, so for one game, we've got $4. And so the number of games is here. So we go over to 1 and we go up to 4. So we give ourselves a dot right there. 3 games is 12. So we go over to 3 and we go up to 12. 5 games is 12. Wait, no, what did I say? 3 games is 8. Golly, Wishart, come on, get it together. That's 3 games is 8. I'm sorry, guys. 3 games is 8 right here. And then 5 games is 12. Right there. Okay. And then 10 games is 22. So we go over to 10. Can we get up to 22? I think we can. Yeah, because it goes by 2s on this. So that's our line right there. So I'm going to just connect the dots here. And I can see that this line does not start at 0. It starts at 2. So what that means is that that shoe rental is $2, right? Because you're paying that $2 before you even start at a game, right? Because if we kind of like reverse this out for 0 games, it's $2, right? So you're paying $2 for that shoe rental right there. So Matilde, that's probably not how you pronounce that, will save $2 if she brings her mother's shoes. So yeah, the price of admission, I suppose. The bowling prices for different bowling alleys shown on the graph below. How much does this bowling alley charge for shoe rental? Well, we kind of back it up and we see where it crosses at 0 games, right? Number of games. If it's 0 games, it's right here. So it's like if this is 2, that's probably 3 right there. So it's kind of right in the middle. So the line crosses the y-axis as 3. So the y-intercept is 3. So the shoe rental there is $3. Ta-da! Okay. We've got a robotic assembly line. Manufactures a set number of parts per minute. Use a graph to identify or to verify how many parts the assembly line manufactures when it's first turned on. So this is where we talk about a proportional relationship. So we can kind of compare the two graphs. It'll be very easy to see, especially if you just look at this graph compared to what this graph will look like. So we know that this robotic assembly line can do 3 parts in 1 minute. And then we kind of have this table which extends that out, right, for every 2, 3, 4, and 5 minutes. So let's just graph these points. We know at 3 parts, and this is, let's see, parts manufactured, and then time in minutes. I'm going to have to go grab my son from kindergarten in just a second. So I think I'm going to pause right here. And that's a parentheses. All right, I'll be back, guys. Not that you will experience really any time difference in the video. All right, guys, back at it. Okay. Parts manufacturing. Right. Okay, so we got a graph. Okay, so parts manufactured per minute. So we've got like 5 points we can put on here, right? We've got 1 minute. It's manufacturing 3. Oh, actually, is that how they set up the graph in here? Let's see here. I might want to reverse this. Let me double check here. Oh yeah, they did time on the X and parts manufactured on the Y. Blech, that sucks. Okay, so sorry guys. I'm gonna do time in minutes and then parts on the Y. Sorry. Okay. And I actually should have reversed these here. So that's weird. Gosh, they did not set up this graph very well. Oh well, it doesn't matter. Okay, so we've got in 1 minute they do 3. In 2 minutes they do 6. In 3 minutes they do 9. Sorry, those are real small, but 4 minutes they do 12. And then in 6 minutes, they do 15. No, 5 minutes, they do 15. Okay, so I'm going to use a new color, guys. I got some new pens. This one. Okay, so we're going to graph this line right here. Okay, so we can see on this line that it starts at 0, 0, and kind of the difference here is that this one starts at 2. Okay, so this is kind of the big difference here. This starts at 0, 0. This starts at 2. So we call this the y-intercept, right? So the y-intercept is 0 here. The y-intercept here is 2. Okay, we call it the y-intercept because that's where it intercepts or crosses the y-axis. Remember, the y-axis is that vertical one. So it crosses at 0 right here, and it crosses at 2 right here. It crosses at $3 right there. And so that is the idea here. Man, I got so many colors. I'm just gonna go crazy today. All right. So now we can identify the y-intercept now that we kind of understand what it looks like in a proportional graph where it starts at 0, 0. Because basically when you turn the machine on, right, it hasn't actually produced anything, right? So it's 0, 0 for that right there. Whereas this one, you've got to pay that $2 for the shoes to rent at the bowling alley. Okay. So this one crosses the y-intercept at 2. This one crosses the y-intercept at -1. And this one crosses the y-intercept at 0. So that is the idea here. And we'll put it together in an equation for the next time we do a series of notes. All right, so we're going to cut this in half, obviously. Put it in your notebook, just like we do every day. We do notes. So this is going on, like, I don't know, page 26 or 27, something like that. Ooh, 28, actually. Okay, so page 28, we're going to call this 2-8. Ooh, that's fun. 2-8, understand y-intercept. Okay. Move that in here. Just like so. All right, cool. 2-8 on page 28. Understand y-intercept. Yeah, there you go, guys.